today's video, we're going to go over getting our scene set up to enable some interactions within the XR Interaction Toolkit, as well as some of the different interactions that are available. Obviously, we're not going to touch on all the possibilities, but give you a head start into designing and implementing some interactions in VR. If you did download the Interactions Demo Unity package, this is the scene that you're going to see. There's one thing we need to fix, and there was one error that I had set up in the XR rig. I had created a script that allowed toggling between the teleporting, so that the teleportation raycast would only show when you press forward on the joystick. There was one error on the right hand. The left hand works correctly, but you'll notice that on the right hand, if we take a look at it, we'll just move this over here. When we have activated the teleportation forward on the joystick, we are enabling the input actions and enabling the XR Ray Interactor. And when we let go of the joystick, we are disabling those. But you'll notice that on the cancel, we are actually disabling the wrong parameter. So we need to change this enable input tracking to be enable input actions and disable that. That will fix some of the errors that you may have been encountering if you downloaded the Unity package with the right hand. So the first thing that we want to do is let's get our left and right hands set up to interact with objects. We're going to both do a remote grab interaction, which means the object could be far away and you can remotely interact with it. And we're going to do the traditional kind of grab interaction. So let's go ahead and open up our left hand. And you see we've already got the left hand controller, which is used for the controller kind of visibility. And we've got one for our left hand teleport. Let's go ahead and duplicate the left hand teleport, selecting it and go Control D. And let's rename that left hand remote grab. And we'll duplicate that one more time and we'll call that left hand grab. And we need to get a few of these set up here to work properly. So let's go start with the remote grab. We want to make sure that we enable our input actions, otherwise we won't be able to track the controller button presses. So let's turn that on. And we're going to scroll down here. And normally when you add in your interaction manager, that does get populated if it's left empty. It's just good habit to populate that. So I'm just going to drag our interaction manager from the scene into that field. And let's turn this on. We had it off for the teleport because we were toggling the teleport on or off. Let's go ahead and just turn that on for now. And we want the interaction layer mask to be not everything. So earlier in the project, I have set up a grab and a remote grab layer. If you're not sure how to set layers, all you need to do is click the Add Layer button. And you can add a new layer by typing it in. One of the things you'll need to do is you'll still need to add that layer to the particular objects, which we'll get to. So if you're trying to follow along this video, let's go ahead and add a grab and a remote grab layer. And we'll pop back into our left-hand remote grab game object. And let's scroll down to the XR Ray Interactor. So we want to change this interaction layer mask from everything to just being the remote grab. So let's unselect it all by clicking nothing. And then we will select remote grab. We'll take a look at some of these options here. So this would be enable interaction with UI game objects. If you want to be able to interact with UI elements, you would turn that off. Later in the class, we'll take a look at UI interactions, but for now we can leave that turned off. Force grab, if we turn that on, what that's going to do is if the object is far away and our raycast, which is the kind of imaginary line, if it collides and interacts with that object, we can, with force grab turned on, when we grab it, it'll, like the force from Star Wars, it'll pull to your hand. If we leave force grab unchecked, we will interact with that object, but it will stay kind of at the distance when you first interact with it. So depending on what you need for your interaction, you'll have that checked off or on. For this activity, we will check force grab on. Let's go ahead and since we copied this from our teleport game object, we had the teleport set as a Bezier curve, but we want this to be a straight line. So we're just going to click this line type, drop down and select straight line. And with the raycast mask, let's change that from everything to being just the remote grab. So we'll select nothing and then remote grab. And this raycast mask basically will determine what objects the raycast will work with. In this case, we only want this raycast to work with the remote grab. And I think that's, the other thing we want to turn on is, we had this turned off for teleportation, keep selected target valid. We want to turn that on. Basically what that means, if we point away while we are still having it grabbed, the object will still stay connected to us, which is what we want. You don't want that for teleportation, and that's why it was checked off when we copied this game object from the teleport. And we aren't going to go over events right now. We will do some events when we get to the lever interaction, but for now we'll leave those as default. And we can leave the line renderer and line visual as a default here as well. So we've got our remote grab set up. And let's go ahead and do the grab. And then you can duplicate the process for the right hand. So for the grab, it's going to be a little bit different. In this case, it's not going to have an XR ray. It's not going to have a ray interactor. It's going to have only being able to interact through a direct connection or a direct grab. So we need to remove a few of these components. So let's go ahead and remove the XR line visual just by right-clicking on the component and remove component. And we'll do the same thing with the line renderer. And lastly, we'll remove the XR ray interactor. But we want to add in an object, and that's going to be the XR grab interactable. Sorry, not the XR grab interactable. The XR direct interactor. Thank you. All right. Again, we want to have this limited to just our grab layer. So we'll select that, drop down by the interaction layer mask, select nothing to zero it out, and then change that to our grab layer. And everything else we can leave as default for now. And so I'm going to pause. You go ahead and pause the video. When you come back, I'll have it copied, the process copied to the right hand. And so go ahead and do that process for the right hand now. All right, so I've gone through and repeated the steps for the right hand. One thing I need to point out for the left hand grab and the right hand grab, I didn't mention it earlier, but we need to make sure that we have enable input actions turned on for both the right hand grab and the left hand grab. Now there's one last step we need to do to get our left hand and right hand grab game objects working, and that is we need to add a sphere collider to those objects. So let's go ahead and select the left hand game object, and we'll just add a sphere collider. And we want to set that to be a trigger, and the reason is we're going to use, this will be used to determine if an object is within like the grabbable space. If we don't have it set as a trigger, it'll be a collider, and it actually will prevent us from actually getting close to our grabbable object. So we're going to check off the is trigger, and let's just reduce the radius a little bit here so that it's maybe 0.25. And so we'll do that with the right hand as well. All right, so we've got that in place, and so I'm going to do a little bit more of getting some things prepped in the scene, and then I'll do a quick test to show you how it should be working, and then we'll continue on. So the first interaction that we want to actually set up here is our ability to open up this lid. So we have this little chest that we're going to throw the ball into, and we want to be able to grab it in VR and open it. Typically, if you were to animate this just through some code and you were to rotate this, currently right now, if I bring up my rotate tool, it rotates it along the center, which is not what we want. But because we're going to be tapping into the physics engine, we don't need to really worry about that, so we can just leave that pivot as is here. So what we're going to do here is we're going to add a grabbable component, an XR grabbable component, XR grab interactable. And we want to set this layer to be our grab layer. So what we're going to actually do is, I already have it set to grab, but you might not. So make sure you select the layer drop down and select the grab layer. And I'll just apply it to the children. And if we take a look at the XR grabbable, we want to adjust this interaction layer mask from everything. So select nothing and then select grab. And if we take a look and we drill down into the lid, we see that we've got this handle, and that's what we want to be able to grab to. So what we're going to do is we're going to drag that handle game object into this colliders list. And what this is going to do, if we just kind of hover over this, it's colliders to include when selecting interacting with this interactable. Okay, so this is what we're going to actually use. And then we want to change the movement type. Default is instantaneous, and so when you're picking up an object, that works. But we want to have this interaction tie into the physics engine, so we're going to change this from instantaneous to velocity tracking. And that is all that we need to do for this. So the last thing we'll get set up is the ball interaction, and then I'll do a quick test, and then we'll continue with the second little bit here. So I'm going to go over to my sphere, and there's a couple things that we want to do. Yep, there we go. First off, I want to be able to give this a bit of a bounce interaction. So I drop it on the table at a bounce. And so we're going to use what's called physics material, which will allow us to simulate that physics aspects of bouncing. So let's go ahead and create a new material. I already have one in here from before, but I'll go through the process of creating a new physics material. So I was going to right click and create, and it's kind of I always have a hard time finding it. There it is, kind of near the end there, physics material. And I'll just call it ball, I'll just call it bouncy. All right, so let's take a look at some of these settings here. So dynamic and static friction is basically kind of the drag or the friction that's going to happen with that bounce. So the higher the number, the kind of more decay that there will be on that movement there. If you were trying to simulate something like ice, you would have these values lower. The bounciness is obviously how bouncy the object is, and that's from 0 to 1. And then the friction and the bounce combine. If you have two objects, so for example, this ball and the table, and they both have a bounce or a physics material on it, how it's interpreted is based on what you select here. So for example, average would take the average of the two bouncy values or friction values. Minimum would take the lower number, multiply would multiply the two values, and maximum would take the higher number. So we're going to leave this as average, but we'll set our bounciness to 1. And we're going to add that both to the table here so we can demonstrate the bounciness and to the ball. So to do that, we'll go ahead and select the table first. And you can see in the box collider there's a option called material. It's not a graphical material, but more the physics material. So we're going to drop our bouncy material onto that, and we'll do the same with our sphere, and we'll drop our bouncy material onto that. So when we do the demonstration, you'll see when I drop the ball, it'll bounce on the table. So now we need to get this set so that we can remote grab with this. So that's what we're going to do with this one, is a remote grab. So let's make sure that we've got the remote grab added to the sphere, which I already have. If you don't, select it from your drop down. And we need to add a XR grab interactable to this. And automatically adds a rigid body. We're going to change the interaction layer mask from everything, so we'll select nothing to zero it out, and we'll select remote grab. And we leave the movement type as instantaneous, that works. And everything else should be good. We're not going to worry about events for this, this demonstration here. So I'm going to do a quick preview, and we'll see if this works here. All right, let's try and catch that ball before it rolls away. So there's the remote grab working. If I had force grab turned off, at whatever point the raycast that you see this red line, whatever point it collided with the object, at that distance I would be interacting with it. So let's see if I can go and what the bounciness is like. So it's quite bouncy. Grab that. But you'll notice that we've got these raycasts that are permanent, and we only really want them to show up when the raycast is colliding with an object that we can remotely grab. So let's go in and adjust the setting that will make it so that these only show up when it's colliding with an object that is tagged as remote grab. Okay, so all we need to do is on our remote grab game object, we'll scroll down to where we have our XR interactor line visual. And we see we've got a valid color gradient, and I kind of have it going from a light blue to a dark blue. And we have our invalid color gradient. All we need to do to make the raycast not visible unless it's actually intersecting with a layer that it can, in this case remote grab, is we'll just change the invalid color gradient. So click on the swatch, and if we click the top icon, we can go ahead and change the alpha, and we'll do the same with the other side of the gradient. And now it will be invisible unless it interacts with a remote grab layer. So let's go ahead and do the same thing to our right hand remote grab. We'll just change the alpha to 0 for both sides of the gradient. Now if I do a quick test, we will see that the raycast line is only visible when it collides with an object that we've got tagged with the remote grab. All right, so let's pop over to our box object. Let's go ahead and click Add Component, and we're going to look for the word hinge joint. Now, hinge joint is not part of the XR Interaction Toolkit. It's actually part just of the base Unity package within the physics components. So what we're going to do is we want to specify what the hinge is going to be. So if we click this Edit Angular Limits button, we can see a visual representation of that hinge. So currently, it's going to try to open along the short side, which isn't what we want. So we're going to change a few things in our anchor and our axis. So we're going to change it from being along the x-axis, so we'll zero that out, and we'll change it to be along the y-axis. Now we can see at least it's rotating correctly, but it's not in the correct spot. We want it kind of at the back of the box here. So we're going to change the anchor position. So we're going to zero out y, which will put it in the middle of our box. But we also want it to be back here a bit. So we're going to move it along the x value until it looks pretty close here. I'm just going to zoom in to kind of get a better look at this here. So it looks like it's a little bit not in the correct spot because it's going to rotate around that little point there. So I'm just going to move it back. Maybe I'll do a minus 0.5. There, that looks better. So now that's kind of right along the back of the lid there. It's going to rotate along that spot. If I really wanted to be accurate, I could put the hinge actually down here, which I'll do that. So I'm going to lower it along the Y, along the Z, so that it's now kind of at the bottom of the lid there. All right, so we've got our hinge joint in place, but we still want it to only be able to open and close within a certain limit, like a traditional box or chest would. So that's where we can bring in what's called these limits. We can check off the Use Limits option, and when we do that, we'll see a graphical representation of those limits, and we can see what those values are represented when we expand the limit section. So if I grab this handle, I can specify what I want the limits to be. So take a look there, and I might have it be maybe minus 45. So it looks like it's perpendicular to the back there. And maybe I'll just, to keep things, another thing I would suggest, and when you're working with these limits, is to kind of have more, less precise values. So this value of 105.4.195, well, it's okay if you're going to start trying to determine that value, which we'll do with the lever. The precise values become a little bit difficult to measure. So I'm just going to set this to actually 105, or maybe even just 100 there. So now when we go to grab this, it'll stay anchored along this back hinge and only be able to open and close within these limits here. And let's give this a shot. All right, so I'm in the scene. Let's grab this ball before it rolls away on us. There we go. All right, so we got the ball. Let's pop over to the chest and see if we can open it up here, and we'll see the hinge and XR Grab Interactable working together here. So I'm going to grab it by the lid, and you notice if I try and grab it by anywhere else, it doesn't work. It only works because we specified the handle as the collider. So I'm going to throw the ball in there. There you go. So that works. All right, so we're back in Unity, so I'm going to hop over to the lever here. And again, it's going to be a similar process up until the point where we want to read in the values of the lever position. So first we're going to start by adding in our XR, grab interactable. We'll make sure that we have this set to our grab layer. If you don't have that set to your grab layer, go ahead and add that to the grab layer. And we're going to adjust a few things. You want the interaction layer mask to not be everything. So we're going to zero that out by selecting nothing. And we're going to select grab. Now we want the lever to only be grabbable by this little knob here. So we're going to plop that in to our collider list, the handle, which is good there. And I think that's all that we need to set on here. We will need to do a few tweaks, which we'll show why and how to do that in a moment here. Let's go ahead and add our hinge joint. Now, I'm going to show you another way to do this. And when I was kind of going through and testing this is kind of the process that worked. You may not need to do the same process, but you'll notice in the hinge joint, there's an option to have a connected body, having this hinge attached to another object. For some reason, when I went through this process worked the best. So we're going to actually make the hinge joint be connected to this table here. And for that to work, we need to select our table game object and just add a rigid body component to that. But we want this rigid body to not move around. We don't want it to respond to gravity. So we're going to deselect use gravity, and we're going to make it is kinematic, meaning that it will not move. Now let's see if it gives us a little tooltip. It does not. But the is kinematic checked off means that it won't respond to other objects hidden in it. So we'll get that set up. Now if we go back to our lever in our hinge joint, we can connect the table to our connected body. And you'll notice that the connected anchor is adjusted based on that. And we want to specify, we want to edit the hinge joint. So if we select edit angular limits, you can see that it's kind of up here. We want it down below. So I'm just going to go ahead and flip to this view here. And I'm going to move it down along the Y to just above right there. And let's see if that's good enough. That looks good. And it's already rotating the correct way, which is great. So we're halfway done. All we need to do is add our limits in place. So again, I'm going to check off the use limits checkbox, and we can specify what those limits are. So I'm going to go ahead and adjust the min. There we go. We'll say the min is minus 45. That works good. Again, keeping in mind that you want to use, for this part, we're going to definitely want to use very specific numbers and not the decimal. The more precise make it harder when we're comparing, because what we're going to do is we're going to compare when the angle of the hinge is at the min value, in this case pulled down, we're going to make the bubble gun appear. If we have a min value that's more precise, it makes it harder to kind of match that up here. So we're just going to go ahead with minus 45 degrees for the min. And we'll leave the max as it is perpendicular to the table. All right, so that's that. So I'm going to go ahead and show this, and we'll see how the hinge joint at least works. And you notice that there'll be a few issues that I'll talk about in the moment when I'm in the demo. All right, so I'm going to pop over to the lever, and I'm going to grab it. Okay, so I know what is going on here. So when I picked it up, it didn't kind of attach with the physics system because we didn't change the movement type. So we need to change the movement type from instantaneous to our velocity tracking. Now if I pop back in there, it will interact with the hinge joint that we just added. All right, that's good that it didn't work the first time, because sometimes when you're working on your project, it may not work the first time. So there we go. So now it's not pulling away, it's just working like this hinge, and you can see that it's not moving past that perpendicular point, that 0 degree, and I can't pull it below that. Now what I want to show you, if I let go, it falls, right? Which isn't really kind of what I want for my lever. I want it to kind of have a bit of friction. So we're going to have to change a few things for that to work here. All right, back into the engine here. What we need to do is a few things. First off, we want to disable gravity on our rigid body for the lever. But that's still not going to quite work for us. We want to make it so that when we let go of the lever, we want it to stop moving. And so we want to turn on this is kinematic. When we grab it, we want it to be movable, so we want to turn off this is kinematic. And we can do that through events. So if we scroll down to the end of the XR grab interactable, we see we've got these interactable events. If we expand that, we can see we have a bunch of options on hover, on select, on activate. Under the select option, we'll take a look at the sample action set we brought in earlier. So the select action is currently mapped to our grip button, but that can be changed pretty easily. But right now it's mapped to our grip button. So when we see the word select in our events, that's what it's referring to. So that's the one we want to target is our grip button. So what we're going to do is we're going to add a couple of slots, one for select entered, one for select exited. And what we're going to do is we're just going to reference the game object itself so we can access the rigid body. So when we activate it, or when we grabbed it, we want to turn off is kinematic. When we let go of it, we want to turn it back on. And what the is kinematic means again is that it won't move. So even though the gravity is turned off, it still has a bit of movement, but this approach here will stop that. And let's do a quick test to see how that works. And I'll grab it, I'll let go, and it stops. It doesn't have the drag or the drift. It stops exactly where I let go of it, which is perfect. Now what we're going to do is we're going to write a line of code that will detect when it's at this max position, and at that point enable the bubble gun. But you could use the same concept to play a sound, to open a door, to start an engine, anything you can imagine. You can kind of have that same idea in place. But for this, we're just going to use it to turn on or enable the bubble gun. All right, we're back in the engine. So we're going to write our first script here. So let's go ahead and click the Add Component button. And I'll just call this script lever. I have one already from the demo called lever script, so I'll just call this lever. Oops, I don't want to select lever script. I want to add a new script called lever. All right, and let's go ahead and edit that. Because we added the hinge joint component to the lever game object, we can actually access that through code. Let's go ahead and create a private variable of type hinge joint, and I'll just call it hinge. And what we need to do is actually tell the script actually what hinge joint we want to connect or store in this variable. So in our start method, we will say hinge equals, and because the script is going on the lever that has the hinge joint, we can just say get component, and we will say hinge joint. And we're going to throw in the update method a if statement. We'll say if hinge.angle, so that's getting the current angle that the hinge is at, is equal to hinge.limits.min. Because remember, when we set it up, the min was the amount of pulling it down, so that's what we're trying to compare it to. So if it is equal to the min, we want to turn on our bubble gun. And we need to create a reference to that bubble gun in our class up here. And we'll make it as a serialized field, so it's not accessible outside of this class, but we can populate it in the inspector. And we'll just say type game object, and we'll call it bubble gun. And then we'll just say bubble gun dot set active is true. So when the lever angle gets to the min, it's going to turn on the bubble gun. All right, we'll test that script in a few minutes here. Let's start with our bubble gun script. So I'm going to pop back into Unity, and we'll just kind of connect the bubble gun. I'm going to keep saying bubble gum. Connect the bubble gun game object just by dragging that in the hierarchy, from the hierarchy into there. Okay, so let's go ahead and with the bubble gun, there's a couple of scripts we've got to do. One, we want to be able to have the bubbles when they get spawned in kind of float up and eventually disappear, kind of like bubbles do. The prefab. So because we want to animate this game object or the bubble through physics, we're going to add a rigid body to this prefab. So make sure that you're actually on the actual prefab, not an instance of it in your hierarchy. And let's go ahead and click the Add Component button, and we will look for a rigid body. And we don't want gravity to be used for this because we want the bubbles to kind of float up. And if we have gravity turned on, it's going to pull them down. So we're going to turn off use gravity. And we're going to go ahead and add a script. And that script will be used to do two things. One, to have them disappear after a period of time. And two, to have them kind of shoot out of the bubble gun and float up. So let's go ahead and add a new script, and we'll call it bubble float. All right, let's edit that script. So we need to reference the rigid body so we can add some force to it. So we're going to go ahead and create a rigid body variable. It's going to be private. I mean, I could add the word private in front. When you have variables that you're declaring at the top, if there's no accessor type, then it defaults to private. But if you want to get used to it, to make sure, you can add the word private there. And I'm just going to call it RB for short. And we need to, again, tell the script what rigid body we actually want to store in this variable. So we can say RB equals get component rigid body. Now we can access and set all the parameters that are contained within the rigid body class. So we are going to put it in our start method because when these bubbles get spawned in, we only need to have the movement kind of start once. And we're going to add some force to it. We're going to add a forward force to kind of shoot them out of the gun and an upward force to give them that float effect. But we need to determine speed and also their life. So we're going to create a couple more variables. I'm going to set them up as serialized fields so I can set them in the inspector. One will be a float speed, and we'll do another serialized field, and we'll set that as another float, and that will be lifespan. Okay. So what we're going to do here is we're going to, in our start method, we're going to add a couple of lines of code to give it that vertical and that horizontal push. So we're going to go and reference our rigid body, and we're going to say .add force is one of the methods within the rigid body class. And you can see here that it's looking for a force. So that's kind of the direction, and we're going to multiply that with the speed to give it that movement. So we're going to say vector3 dot forward. Oh, not vector2, sorry, vector3 dot forward times. Now in this case, when I was doing some testing, this worked out best. You need to tweak your numbers the best that you want if you wanted to recreate this interaction. But I'm going to go times speed divided by 2. Otherwise, the forward movement is a little bit too fast. And then we're going to specify the type of force. So I hit force mode, and I hit dot. You can see there are 4 options here. So acceleration adds a continuous acceleration. Force, if I just kind of go over that, it adds a continuous force to the rigid body using its mass. Impulse is a kind of a burst using its mass. And then velocity change is an instant velocity change ignoring its mass. When I was testing this out, what worked best for the bubbles that I wanted was the force mode velocity change. So I'm going to use that. You may want to experiment to see what works best for what you're trying to accomplish. And that's the forward, but now we need to give that up movement. So we're going to do another add force, rb.add force. This time it will be vector3.up, and we'll just times that by speed, but without the dividing by 2. And we use the same force mode because that, again, in my test worked best. So when this object's going to spawn into the scene, it's going to get the rigid body and then add a bit of boost forward and upwards to create that animation effect. Now we want to have the bubble to disappear after a period of time, and so we're going to set that in our update. You could use a coroutine if you wanted, but for simplicity's sake, I'm putting it in the update. And what I'm going to do is I'm just going to go, have an if statement. I'm going to say if lifespan is greater than or equal to 0, we're going to reduce the lifespan by 1 by using time.delta time. If it's not greater than or equal to 0, else we're going to destroy the bubble. Now later on in the semester, I will talk about some performance techniques that would involve not destroying it, because the idea of destroying, while it does prevent a lot of objects from being in your scene, the memory management or the garbage collection to deal with that is a bit of a hit. All right, so we got all our scripts set up for our bubble. Let's go ahead and hit save. So we'll just set this, or sorry, the speed and lifespan. So I'll set the speed to 0.5, and the lifespan would be like in seconds. So I'll say like 1.5 seconds, 1.5 seconds. All right, so that's the bubble, which is there, which is great. Now we need a script and set up our bubble gun. So the first thing we'll do is we'll set that up for interactable. So we'll go ahead and select our bubble gun. And I'm going to add a XR grab interactable. Make sure that's on the grab layer, because I don't want them to be able to remote grab this. I want to have them pick it up. And we're going to change the interaction layer mask from everything to nothing and then back to grab. You'll notice that we've got a handle that we want to be the collider. So I'm going to drag the handle in, not for the lid, sorry. Oops, that was my bad. We have a handle. I'm going to drag the handle into the colliders for the XR grab interactable. Come on. There we go. Oops. There you go. I'll leave the movement type as instantaneous for the grabbable. That's kind of what we want. And I think that's all that we need here. Now, one thing you'll notice, if I do a quick play, you'll notice that it's grabbed a little odd. And we're gonna talk about why and how to fix that. So if I pop over to the table and I grab the bubble gun, you can see that I'm holding the gun upside down and I'm holding it right at the base. Okay, we're going to fix that so that we're holding it at the handle and that the gun is rotated correctly when we grab it. So let's go ahead and take a look at that. All right, so back in here, we're going to go ahead and create an empty game object under our handle. And I'm just going to call it grab point. And from my testing, I realized, and you may need to do your own experimentation if you're applying this process to another interactable, I need to rotate the grab point along the z-axis by 90 degrees, and that will get it so that when I grab it, it's flipped the correct way. So I'm going to change that to 90. And if I take a look, oops, I added the grab point again to the wrong handle. So I'm just going to move my grab point to my handle game object. And I'm just going to actually zero these out. And I'm going to change the scale to 1 for those. Okay. All right, so that's good. If we take a look at the bubble gun, there is, under the XR grab interactable, there's an attach transform. So the point, it's basically the grab point, the point you want to attach this object or this XR interactable to. We're going to select the grab point that we just created, drop that in there. And so what I also want to do is with that grab point, I want to move it down a little bit. So I'm going to grab it here, and because I rotated it along 90 degrees, it's going to have the bubble gun kind of correctly positioned in my hand. And let's see how that looks. All right, let's go to the bubble gun. I'm going to grab it. There we go. So no longer am I grabbing it up here by the kind of barrel, but I'm also grabbing it correctly so it's not upside down. All right, well, let's go ahead and add some interactivity so that when I pull the trigger on the controller, I can see those bubbles appear. So we got one more script to write. The first two scripts were more so working with the physics system within Unity, this next script will focus on kind of connecting in with the XR interaction toolkit. So let's select our bubble gun and let's add a new component, and we'll just call this bubble shooting. And let's go ahead and edit that script. Oops. Where did it go? There it is. Let's edit that script. So because we want to tap into the XR interaction toolkit, we need to add a new namespace or library. So at the top, we're going to go ahead and add using Unity engine.xr.interaction.toolkit. That will allow us to access the functions that we need to. We also need to specify what prefab we're going to instantiate in. So we'll do a serialized field, and we'll say game object, and we'll just call it bubble prefab. All right, so now I need to create a reference to our XR interactable. So we're going to go ahead and make it private, and we'll say XR grab interactable, and I'll just call it grab interactable. Again, doesn't matter what you call that as long as it's contextual. And we'll change this to awake. It probably would work on start, but just remember the order of processing. Awake comes before start. So we'll just put this in the awake. And we're going to create the reference to this grab interactable. So we'll just say grab interactable equals get component XR grab interactable. And we need to add a event listener. So events are a way for part of the event system within Unity are ways for you to have your code respond to events and listen for those events. As opposed to having things always running in the update and checking, this is a more performant way of doing that. So we're going to add an event grab interactable dot activated, and again, activated is referring to the activate action, which in this case is set to the trigger. So we'll continue this on. So activated dot add listener. So we want to add a listener, and when that action is fired, we're going to listen for it and then fire a function. So add listener, and we'll just call this function that we want to execute fire bubbles. All right, so this error message is telling us it doesn't exist, but now if we click the little show potential fixes, hit Control Enter on our keyboard, it'll create the method for us and pass the proper parameters, but we can delete this line as we don't need that. So all we need to do here in this fire bubbles is instantiate our bubbles. Now, there are a couple ways of doing that. In previous classes, we've gone game object, and we gave it a temporary name bubble obj equals instantiate. But we don't need to do this process because instantiating it this way worked well if we had to reference after it was spawned in properties or methods of that object, which we don't need to do. So we can actually just go in and type instantiate the prefab we want to instantiate in, which I think I called bubble prefab. And the other way we did it in class is we passed the prefab, we passed the parent. So if you look here, this is the approach that we've done in the past where we attached the parent and where we specified if it was in world space. So I'm going to do this to show you what will happen if we take this approach. So I'll say, well, one other thing we need to specify at the top here is where are we going to spawn it. So let's go ahead and set up another serialized field, and we'll call it game object, and we'll say spawn point. Now here, if I go down here and say spawn point dot transform, and I'll say that we don't want it in world space, so I'll say false. So this isn't going to work the way we want, but I want to show you what it does, and then I'll show you how we want to fix that. Okay, so what we're going to do is, I think we've got our script all ready to go. Let's save. All right, so let's select our bubble gun and go down to that script. We need to drop a few prefabs or objects in here. So one will be our bubble prefab, so bubble student. And the other one will be the spawn point. So we already have a spawn point in here, which I just put just ahead of the barrel. we'll drag that spawn point game object down into that field there. So now if I go ahead and let's see if the lever piece is going to work. So let's make the bubble gun disabled to start. And let's see if the lever will work. All right, so I'm going to head over to the lever. Right now our bubble gun is not there. I'm going to grab the lever and pull it down. And there our lever triggered the gun to appear. Now go ahead and grab the gun. Now if I hit trigger on the controller, I can see that the bubbles are working, but if you notice, they are really small, but they also look like they're oblong. And I'm going to tell you why that's happening and then how we can fix that. All right, so let's just enable us for a moment here. So back into Unity, we'll take a look. So here's the bubble gun. I just created it as a primitive and stretched it out to be an oblong rectangle. But you'll notice here in the transform, the scale is not uniform. Okay, so we've got the X and Y are the same, but the Z is different because I stretched it out. When you're dealing with objects, game objects where the scale is not uniform, children objects of that will either distort incorrectly when you rotate. They also will have weird things happening to them through scale. And so that's why when I spawned in the bubbles that were a child of the spawn point, even though the scale is correct here and it's uniform, the parent object is not, and so the bubbles came in distorted. Typically when you're working in Blender or Maya and you're bringing that in, it's going to be kind of scaled and stretched the way you need to in the 3D program, and the scale inside Unity will be 1:1. It's a relational scale, not a unit scale. And so you need to make sure when you're working with objects that have children and you're looking at movement or rotation or scale of those children objects, that the scale is uniform. So what we can do to fix that is just change how we spawn in those bubbles. So rather than making it a child of the bubble gun, we're going to just get the position of the spawn point and assign that to the bubble. The other issue with having it as a child of the spawn point is when I move my gun around, it's going to have the bubbles follow that because they're going to be children of the bubble gun. So that's another negative effect of this process. So all we need to do is just change how we set that up. So we're going to say spawn point dot transform dot position, and we're going to specify. We'll just scroll down here. This option, the quaternion rotation. I'm not going to pretend to understand what quaternions are, just to explain that they are a way of interpreting and working with rotation in a 3D space. So all we need to do for this is say quaternion, and we're going to use the property identity, which is really just kind of reading the rotation of the object that we're spawning in. So we'll just select that and that there. So now if I go and hit save and pop back in, now if I play, the bubbles will be the proper shape. They won't be distorted either. Grab it. There's my bubbles, and they look correct. They're not too small. They're not distorted. And we do see that they are kind of disappearing after 1.5 seconds.